Okay, so welcome to our weather discussion. I'm going to turn some lights on. We've got a different complexion to the weather this week than we had last week.
Just see that area sinking down by the 300, like at the bottom of the bottom.
Yeah.
You see that flow of cirrus clouds toward the south?
Mhm.
That's where that western jet is being formed. That's merging into a western jet at the equator.
So as Pete always puts up a couple of different movies from the last week, this is to the Pacific coast. We were noting, I guess we're near the end of it now, we were noting there was, earlier in this movie, there's a flood of cold air off the continent at about the longitude of the Gulf of Alaska. This is somewhat uncommon. We don't see that all the time every winter. And my comment is that's the worst place to flood cold air off of the high latitudes because it gets modified so quickly that it doesn't really have a lasting impact.
So that's bad because
some of the statistics. Well, I just like the statistics. We're running, I'll show you later on the time series, but we're running as the third warmest winter of the last 72. And we were in December, the warmest December of all time by the 850 cold pool extent. So, and we're not going to get to the top of the list because 2014-15 just unbelievable in February. And we're already well above that now. It's going to take a tremendous miracle for us to break to the top of the list for the December, January, February. But we might finish third. And it looks like second place is getting increasingly out of the realm too. So, okay, let's go to, let's take a look at our current satellite over the continental United States.
The lower left corner, is that the hurricane or the cyclone Damien?
you can bring the image back up.
Yeah, there's the lower left.
Oh, here.
Yeah.
What's it called, Duo?
I think it's Damien. I'm not following it, but it's
Damien, you said?
Yeah.
I haven't paid any attention to the
Yeah, where's the
tropics
equator
or
on
Pacific,
this?
so I couldn't say.
I don't know. I just should be just.
Well, here's Hawaii, that's 23, so that's 20, that's 10.
Where's
The equator is down here, I guess.
Yeah. But maybe just a cluster of fun,
And that's at about the date line too, so that's a, to give you an idea of longitude, I think 180 is
It
right
got
there.
overshooting tops.
I can't hear you, what did you say?
It got overshooting tops.
But yeah, that's
Overshoot.
not, Damien's on the east coast, or sorry, west coast of Australia,
Okay.
so that's not nearly far enough.
If it's today, we could probably see it on a hemispheric view.
Okay, one of the big stories today, and there's always more than one, but one of the big stories today is this massive cyclone now really getting itself put together over the Canadian Maritimes and the Gulf of Maine. And you can see some of the basic characteristics of it. There's a cold air outbreak that is in its wake, which I think probably has something to do with the cloudiness down over the isthmus. I don't know if it's making any progress towards Tehuantepec, but it may be. We might see some outflow through that little narrow gap in the mountains there. But here's the cold frontal cloud band associated with it. And earlier today, you can see the reflectivity, maybe we still can in Miami, pretty decent continuous precipitation associated with it. You could see a little bit earlier in the day off the coast of Cape Hatteras, but now it's probably moved too far to the east to be picked up. We'll see when we go to the national radar. But one gets the impression, just putting a couple of those pieces together, that this is probably a fairly continuous band of moderate to heavy precipitation. It's got a rope cloud that's got a long synoptic length to it too. It's really kind of an interesting looking feature. Then there's the big cloud head that has a continuation, a rapid and lengthy continuation off to the east. It's thin cirrus over this location. You kind of get that sense when the sun's going down. You can see through it a little bit. It's a little bit thicker over the maritime provinces where I think it's probably precipitating rather heavily. We'll notice some interesting temperatures from today. There were temperatures in the mid 50s in, I think, Atlantic City, and it was 35 or at one point in Philly. So a huge temperature contrast on the western side of this thing as the cold fronts come through. And then a large part of western Pennsylvania, western and upstate New York, and parts of Ohio, northeast Ohio, were under some snow. And last night it was snowing in Detroit. There were delays there, and much of lower Michigan was snowing. And we've been sitting here all week enjoying several days in a row of sunshine, which is somewhat unusual because we had the whole last 10 days prior to that. It was cloudy without cessation. And yet there's been storm after storm, either moving past us to the north and east or past us to straight east. And we've just been sitting here enjoying a nice week. But this has been a wild weather system, and it's characterized by a number of interesting features, one of which we'll see when we go to the upper level charts. There's a jet at the mouth of the Labrador Sea at 200 millibars. I think it's over 200 knots. So one of the more unusually strong jets of the winter. And we'll try to do a little bit of looking at that with vertical cross sections and whatnot to the extent that we can. It's difficult for me to put it all together the way I like to in the fall because I have class in the morning on Friday and I can't get to the Viz 5D and things like I can in the fall. So that's unfortunate today. It would have been nice to have that ready. Can't do everything. And here in the central United States, low clouds, and some of this is, almost all of it's moving, so none of it's really snow cover on the ground. It's kind of low clouds, and we've been familiar with them for much of the month, actually, the last couple of weeks, with a nice period of respite this week. And then on the West Coast, the immediate impact of weather systems is a little bit remote. It's a little further to the west. We'll see that in just a minute when we look at the West Coast satellite image. One thing, even in the visible that you can see, we'll see it better in the infrared, I hope we go there in just a second, is you can see the broad contours of a really deep continental trough. Because even all the way from the border of British Columbia with Alberta, you can see cloud elements in the visible moving straight to the southeast toward Louisiana. So that's indicative of being on the eastern side of an upper ridge axis, and then here's the western side of the upper trough axis. So it's pretty deep. And so the potential for many places getting colder than they've been in quite some time is there for the next few days, and we'll see that.
I mentioned that Colorado's been getting some significant snow today.
Yeah, Denver had a lot of
Currently
flight
still is.
delays yesterday.
What's that?
Denver had a lot of flight delays yesterday, I heard.
It's still snowing right
Is
now.
that right? Yeah.
And my wife Bonnie, she's been driving through Georgia, and she says it's switching between rain and snow.
Oh, is that right? Wow.
In the Atlanta.
Yeah, wow.
Yesterday, my friend down in Austin sent me a picture that it's 32 degrees and there's snow on the ground.
In Austin, Texas.
Yeah,
Wow.
the day prior, it was like 80.
So this is about the time of year, I think it was February 1st and 2nd, 1895. It's one of the most historic cold snaps ever in the central United States and southern United States. Places get below zero that never seen it again.
Did you mention this Lubbock storm? I mean, I think it's the same one that always like, they had like 14 inches.
Oh, is that right?
Yeah,
You can
big
see the
one.
snow still on the ground.
Is that right?
It's still melting, you can see it in the picture.
What's going on?
Oh, please, as a loop from one of our alums, Zach Hamlet sent a loop of snow in Georgia this morning. First snow we'd seen all year.
Oh,
But I just wanted to show you how
you stopped.
somewhat impressive or unimpressive it is. But he gave permission for this to be shown. So look very carefully. There's also an audio. I don't know if we'll be able to pick that up.
Yeah, I don't know, we'll see if this even plays, hopefully it does.
At some point he says, look at the black door, the dark door. You can see a few flakes. This is snow excitement in Georgia this morning. Look carefully, you might see a. I did see some flakes in there, but
That's a snow squall in Georgia.
that's a snow squall in
They
Georgia.
closed
this
schools
morning.
for that, right?
No, I don't know if any closed schools, but.
Oh, yeah, you can see some.
It's like the snow we get excited about.
Oh, yeah.
That's
right, yeah.
Great.
There's a couple of snow flurries, so. Okay.
So thanks for that contribution, Zach.
Yeah, thank you, Zach. Sorry that your drought continues, but you knew the risks.
Yeah,
So-
northern Texas, you can see the snowpack.
Oh, yeah, there's some snow right there. So there's the Lubbock
Yeah,
snow
that's-
event.
yeah.
So why is it so mesoscale? That's kind of interesting. I don't know why that's.
Well, it was elongated. In fact, it extended into Mexico a little bit.
Oh, is that right? Down
Yeah.
this way then? Oh, that's very interesting. Yeah, I didn't notice that.
That's all that's left.
Okay. So that's interesting. Snow down in Lubbock. Well, I don't know what, someone else has to describe this. 'Cause I-
Well, just the bright green areas are where it's snow. So there's snow here, snow there. The yellows and oranges are high clouds, the light blues are low clouds, dark blue is ground, and the bright green there, anywhere in here is snow.
Okay.
So,
Should we take a look at the infrared picture? Maybe just so we can see a little bit more. Yeah, this is okay, because you can see the evidence of some of the cloud elements, higher elevation cloud elements moving straight southeastward in the big flow downstream of the ridge. So one might guess that the coldest temperatures at upper levels are going to be somewhere over Missouri, Arkansas, as a rough guess. And when we get to 500 millivolts, we'll take a look at that.
Right. And the surface cyclone that's over the East Coast, just I guess over Long Island Sound right now, shows up really nicely as well. You can see the low cloud swirl
Yeah.
as it moves just over east of Iceland. now.
Yeah, when we take a look at the radar, you'll notice, I think you can see it even here. Can we step through this, Pete?
Yeah.
Yeah, okay. Go a little further ahead. Washington, Massachusetts, this little cloud band right in here. And then it's going to get a little colder at the top, and then there'll be another one that comes in behind it.
we can zoom in on that if you want.
Yeah, we will, I think eventually. I just want to point it out even here. Anyway, maybe that's the major striation. There's another one further north. I wonder if there's some sort of gravity wave activity going on right in that location. Because you can see these things lining up
Yeah.
that seem to be just about perpendicular to the shear or something.
It's like a
Yes.
972 low that's deepening to the low to mid 960s over this afternoon.
Yeah, so there's a lot going on there, so it's interesting. So when we look at the radar, you'll see that actually that's precipitating. There's radar elements, echo elements there, so pretty neat. So this is a really interesting story, and there's a lot of things to it. There's a deep cyclone off the coast of Greenland, and then there's this, westerly flow at the top level of the high latitude edge of the cloud mass. So you can imagine there's going to be a confluence zone right about in that location, and that confluence zone is fueling a really intensive jet in exactly that spot. So really interesting. So before we take a look at some of those upper level shots, let's look at the surface maps. The radar display first, sorry. Yeah, so watch these radar elements across Massachusetts. There's certainly a striation there. See that? I don't know if we won't see anything in a single surface map with any gravity wave signature in the the paragraphs, but it'd be nice to kind of look at that because there's definitely something interesting in that structure.
Could those be symmetric, sight-wise symmetric?
I don't know, that's a pretty highly curved portion of the storm. I don't think there's any way you can hold that theory together in such a highly curved flow.
Well, that's when it happens, in curved flow. It's symmetric.
No, but the theory doesn't apply in curved flows. It has to be perfectly 2D.
2D and symmetric curvature. So I mean, if it's actually symmetric 2D, then it applies. So we'll put about.
Yeah, okay.
Yeah, but yeah, it's curved flow.
Okay. So here you can see look at the difference between the more well delineated echoes in the warmer part of the storm and then the fuzziness where it's snowing. It's really evident many times. And there's snow continuing in Denver and also to the north and west in some of the high plain states and parts of Idaho. And here's a portion of that precipitation is off the coast of Miami. So one imagines this is continuous all the way up this way, just off too far offshore. Okay,
John, question.
yeah, sorry.
Are those gravity waves what caused the errors in some of the model runs?
I don't know what errors you're referring to.
I think it was a novel a couple days ago, and then the Euro yesterday, they had, I don't know, I'm not very well versed, but they had, mesolos everywhere.
Oh, I don't know. That might be. I was because I'm waiting to hear what the question was in detail, because this would be a mesoscale influence probably, and I'm not an expert on gravity waves, but they would probably have some tendency to screw up on the mesoscale what the forecast is.
Right.
But probably not on the
I
synoptic
think,
scale.
I
And
think
then maybe that's
referring to, but I don't remember if it was the,
There was
on
something
top of it.
on the map.
Yeah, the map mailing list the last couple of days they're talking, that was where the boundary of the NAM they were
Oh,
talking
okay.
about. So I think, yeah, you're perhaps right that
Okay.
these could be mesoscale phenomena that are embedded in this very deep cyclone. But I don't remember all the details of it, but I think you're on to something.
But the models have plenty of resolution to capture those.
Right.
It's just that those are not predictable.
Yeah.
Right, so the sense is that
Yeah.
it's really small scale, high resolution run that was being done. And they look odd, but they could be a consequence of this. It could be reality, but it's just something we're typically not used to seeing.
And Kaylin, what's really cool is it will show a cross section through this jet, and you can see the tropopause has all sorts of striations on the anticyclonic shear side, right where these things would be banging into it. So there's something about them that is known by the models. I don't know what they do with it. That's a good question. That's a really good question. Okay, can we take a look at the surface map, Pete? The large US one. So let's see. Snowing in central Minnesota. Over here is really interesting. Look at some of the wind and temperature differences. It's southerly winds at Providence, southerly wind at Martha's Vineyard, and then northeasterly at Boston. Temperature difference 15 degrees almost, unbelievable.
Providence went up 4 degrees in the last hour. The only reason I know that
Is that right?
Who's forecasting for Boston? What did you go for your forecast time?
I decided to stay low.
Sorry. She's crushing me. She's crushing me in the
That's an
forecasting.
excellent forecast. 43 with a northeasterly.
It's supposed to be 50. The atmosphere got it wrong.
The loss yesterday was like at 57, because there was gonna be like this warm advection right there.
That's great.
Right along Boston, it was a horrible forecast to make for a last month.
It appears to have been the right one.
Well, just
at
wait,
least
just
to this
wait.
point. Yeah,
The warm air is not that far
it's
away.
52 degrees,
Provincetown.
52 degrees and saturated at Provincetown.
Right.
52 dew point. And it's a 52 dew point at Martha's Vineyard, 54, 57, 54. That's the highest dew point at Providence, 54.
The lowest
So,
tracking to the northeast.
unbelievable.
Just wait for the wind to
And the lowest pressure in the vicinity of this is like 973.7, and that's at, is that White Plains, or that's not Albany, Albany's here, that's White Plains, right?
No, White Plains is on Long Island.
So 973.7. So center of the cyclone's right about here over Long Island Sound, just like you said, Guilford, Connecticut area. So, probably 972 right now, and that's not where it's gonna stop. Heavy snow at Burlington, look at that, 23 over 20. That's excellent.
And Albany's what, 34 over 30 with ice pellets?
Yeah, that's right. Terrible for them. That's absolutely terrible. Nobody likes that. Field of snow burn up there. Oh, awesome.
Sorry, what'd you do for winds?
Freezing rain up in Augusta, so pretty ugly day in New England across.
So we're looking at winds right now, so
I went 35 or 36 knots.
35, yeah, 35 is right, yeah. I'm hoping for 35.
Okay, a little bit of light snow across Iowa this morning, as I think we saw on the radar. There's a little bit in Missouri as well. And then some over Minnesota and parts of upper Michigan. Some of that's
And what's really neat about that, there you can see a small circulation just to the east of Des Moines, right? You can see also minimum in the sea level pressure as well. So it's a weak trough for a weak cyclone.
Oh, right in
Right,
here almost, yeah,
Yeah.
it's too bad we don't have a wind there, I don't know what's going on there, but yeah, there's something like that right there. Yeah. And it's 10:08, 10:09 or so.
I'm not sure if that counts as a cyclone because it's over Iowa, nothing counts there yet.
Yeah, wait a week, we'll find out what it is.
I'm thinking that this, on the New England, that's a coastal front there that is typical. That it's kind of like
That's right.
in Colorado, that's more of a Kelvin wave effect trapped up against the mountains.
That's right,
And,
that's exactly right, very good point.
so there's a very strong gradient right along the coast. It's the forecaster's nightmare.
Right.
Yeah. And it accounts for lots of disappointments for me when I grew up in Peavey, right there. And there were times where we were well protected by the coastal front. We were cold enough that it was gonna snow. There were times where we were cold enough at the ground that we got freezing rain, which was a mess. And then there were times where it was just the floodgates opened and the thing went all the way to what boundary?
495.
495, because the hills get higher up into the west. So to 495, then they're well protected in central Massachusetts, but the coast can go either way, especially the north coast. And there were days where, and this was in the 70s and early 80s, when there was no chance of getting that right.
Right.
And I was disappointed more often
But
than
look
not.
at Portland, Maine and other places of down East Maine. You
Yeah.
can see the northerly wind is just locked in there. I don't know if that's just, is that a cold rain and
Yeah,
there's
it's
snow?
33 and moderate rain over
Right.
29. I don't know why it isn't snowing, because it's got
the warm
room to
air
move.
just come in?
Shallow.
Or there's no ice at all until you get way up above the ground. That's gotta be it. You can't supplement water. You can supplement ice, so you need ice.
But Boston will
Should be
turn-
doing it.
Boston will get a stronger easterly component and or southerly component and they'll warm up, so I'm not worried.
Doesn't sound like you're demonstrating a lack of concern. And then a couple of places in Pennsylvania with moderate snow, like Pittsburgh, yeah, that's Pittsburgh, moderate snow. Okay, so can we go down to the south? Let's take a look at what's happening across the Florida Panhandle. All northerly and northwesterly winds. Dew points have plummeted. Look at this, dew point in Daytona Beach is lower than the dew point in Providence, Rhode Island right now. They don't say that very often in the winter.
You can see in the Bahamas where the front is, you can locate.
Oh, yeah, look at that, 66 over 64, and this is the Grand Bahama, 81 over 73, or near it anyway. 15 degrees and a 9-degree dew point drop, that's where the front is. And we saw, and it's, even in the north coast of Cuba, it's made its way past, so it's right about there, so. Okay, let's take a look at the 500 upper level shots. Unless somebody wants to take a survey of the west coast, there doesn't seem to be too much happening.
Snow in Colorado.
Yeah. Yeah, the super Pete's on the ticket. Let's go to 500 first. So there's your 12Z analysis, and there's the deep upper trough that was evident in the satellite picture. So you can see the flow coming straight to the southeast towards Texas, Louisiana, and then straight northward along the coast. But take a look at some of these winds. Kalen pointed this out to me, or Jake did. There was some place that had nearly 150 knot wind. This is 135 at, that's not Raleigh. What is this? It's not Asheville.
Sure, okay, that should be fine.
I don't know if they moved the station there. Anyway, it's in central North Carolina. 125 knots at Atlantic, not Atlantic
Wallops
City, at what? Wallops Island, yeah. So widespread 100 knots at 500 millibars. Tremendous temperature contrast. We're in the low minus 27, minus 28 range on the western side of that. That's the cold bubble. And then it's warm to minus 10, minus 12 on the coast. So that's an extraordinary temperature contrast in strong southerly flow. And there's cold advection in cyclonic shear, except you're down shear of the upper wave. So the subsidence that might be induced by one component of the forcing is probably overwhelmed by the ascent by another. So one has to add them together.
John,
Yeah.
here's a question. If I just showed you this map, you knew nothing about what was going on at the surface, would you imagine a 972 low in New England?
No, I would not. I would think it would be a stretched out coastal disturbance. I think there'd be a chance for some decent precipitation, some of it snow and some of it, unfortunately, warm rain. But I wouldn't think there'd be a concentrated cycle.
And
No
you see
way.
the curvature max all the way down in eastern Kentucky,
Yeah, right.
and just in that region right there, but there's not much of a downstream ridge, at least at this time. So, I mean, we're going to look at the evolution of it, but this is a really curious setup for such an intense storm.
Yeah, the one thing that it wouldn't work to solve or to explain it to me, but there's a broad confluence zone, kind of right along the St. Lawrence River.
Right.
And so there's going to be ascent on this side of that entrance region, of this confluence region. And maybe it's a little bit unusually strong because the temperature contrast is strong, but it's not going to focus vertical motion in one spot. That would be my guess. I'd say we have a linear band of ascent, and so everything gets stretched out. I would never guess this is the case. I'd be interested in this, and we'll all be interested in this on Sunday. That's an interesting little disturbance with a nice baroclinic signature to the north and west of it, and which maybe has something to do with it curling up. But I would definitely agree, that wouldn't be the thing I think.
I think, to me, the whole thing is obvious because of the intersection of these two jet streams. Actually, the beginning of the intersection is almost right over that point.
Yeah, but,
So there's a huge acceleration of flow along.
okay, but the question was this map.
If you just had that map,
Oh, wow, I mean, yeah, you can't see what's going on.
Okay.
But what's going on above it is everything.
So let's go higher. Let's go to 300 first. So at 300 millibars, we got a really interesting structure here. This is a really almost continuous, intense jet, all the way from the Aleutian Island chain to Iceland, pretty much, or south of Iceland. You can't read it as well as I can from up close, but this is 204 knots, okay, right there in the core, south of Greenland. And that's zonally oriented, more or less. Not exactly, but almost zonal. Don't forget the projection's a little funny. And then even down over Carolinas, you're at 181 knots in the core of this. So widespread 150 or more knots at 300 millibars. And then it gets more intense over the Maritimes and to the east of the Maritimes. So this is a really impressive eastern side of this upper trough. It still I would not say to myself looking at this, oh yeah, this is a place where we should have a 972 millibar low getting itself organized over Providence, Rhode Island. I wouldn't say that. And let's go to 200 millibars. So this, we can be sure we're above the level, traditionally anyway, of the polar jet. 225 knots right here over just north of Newfoundland. So, Caitlin, we got to draw a cross section through that and drop the tidbit at 12Z and see what this looks like in just a second. And then this starts to look maybe ever so slightly more likely to be driving development. But I still would say it's going to be an elongated development. If I'm in a 452 discussion and somebody says, I can see a cyclone developing right over Providence, I'd say, you got to explain that to me.
Pete, could you bring up those NMS plots, the jet stream plots?
There you go. You're going to explain it. I'm not. And then we got to go to tidbits. We got to see what that looks
Just
like.
get this 61 here. Just go sit it up first. Just get the first frame and stop it. So this is from midnight last night. Here's your subtropical jet coming up here with the warm colors. Here's the polar jet coming in here. And this coming around here is the polar night jet. And the polar night jet is up from about 20 kilometers up to 35 kilometers or so. So it's way up. And when you look at this three-dimensional picture of 40 meters per second of polar night jet, the top part is cut off because this plot here only goes up to 25 kilometers. So this jet is much above 25 kilometers. So what you're looking at here is into the jet. And what you see happening are the polar jet and the subtropical jet are entering inside the polar night jet. So this has become one continuous jet starting from right around here all the way up into the upper stratosphere. And you can imagine the thermal wind going right down to low levels is accelerating this flow. That's why you're getting 225 knot winds, because the combined thermal winds effects of all these effects, the thermal wind in the stratosphere, the thermal wind in the upper troposphere, the thermal wind down lower, these are all building that velocity right down to extreme dives right in here.
So
I
deep
don't think
layer.
I've ever seen such a robust intersection of these jets like this.
So this deep layer of baroclinicity, this temperature contrast over a very deep layer giving them.
Yeah, and it's accelerating the flow right here. And there you are, there's your low pressure.
Well,
No, that's a little too,
can we at least let's go to 18D, go 2 clicks ahead to the 18D time, because the storm was it was deepening during this time period. It was probably over the mid-Atlantic at this point. Just to match the times of what we're currently looking at.
Okay, this is
it's
18.
close.
So, yeah.
You're definitely right, it's close, but it doesn't, it's not a
I
silver
think,
bullet.
this is, look around the globe, there's nothing like this anywhere else, and you won't see it.
No doubt.
You haven't
That's
seen
true.
anything like this for months.
No, I agree.
So
Maybe the
this
last time was when we were in Germany,
Yeah,
right? With the big rain here in October.
but this is creating this very strong acceleration of flow by the combined thermal wind effects. It's accelerating the flow here, and that's sucking air right from the ground out of the column, and that's lowering the pressure.
That's sensible, except that I still don't see why it's focused in one spot.
Because the intersection's in one spot. The stuff isn't everywhere, it's only here.
The cyclones,
Those things are coming together at that point. Cyclones are an effect, they're not cause.
right, the cyclones.
No one's suggesting that.
The effect, they're an effect of this intersection that's making this stuff happen. I'm pretty sure. We ought to study this, and
Yeah,
I mean, this is
100%
really
want-
interesting stuff.
I think it is.
You know, your
I
BIS
would agree
5B
with that.
files are online now. We could pull a cross-section up there if you wanted to look at that.
Sure,
We're not
if you
looking at these, but, Ketzel Levens is watching the stream. She asked, how common is it for the subtropical jet to be that far north?
Oh, it's
It's pretty
common.
common.
It's common.
It's common enough that it's one of the sort of the routine things that it does. This is actually on my diagnostics page for trying to find superpositions for
Right.
polar and subtropical jet. There's more than a few of them that have populated the East Coast this week, and there's one up over the Maritimes right now. So that's why it's interesting to look at a cross section. I'm not disputing that there's something really going on there, Greg. I just think I need to know why this is the focus region when the jet's further than one. That's all. And you're right, it's definitely worthy of investigation.
That's where the
Something going on.
divergence aloft is.
So you're saying that's like the
Region side.
entrance region to this
Yeah.
very deep jet?
It's the entrance region to the combined baroclinic zone.
That could well be. We see even at 200 millibots, you see a little bit of evidence that there's finally a coherent jet feature out of this. It wasn't so coherent for that.
That's where all the air at those high levels is going 220 knots. That's where it's all accelerating, right there. And that's what's drawing air out of the column and lowering the surface pressure.
So it must just, I still don't get why there to there is that.
This coastal fronts and other things going on that will focus it in one place.
But it's worthy of investigation. I
Yeah.
don't disagree at all. So it's definitely an interesting story. And you can see again here that here's the subtropical jet core. And then here's the polar jet, the top of it, the top isotachs of polar jet are further up. And they do look like they're kind of right together with each other, or nearly so, along much of this length. And that makes the wind speed
You're
stronger.
entirely missing the polar night jet, which is
Yeah.
also extending.
Which is
down
another
the
thing,
bottom.
right? I was just gonna say that when you have regions of baroclinicity in different elevations of the atmosphere, the polar jet is lower than the subtropical jet, but when they get close to superpose, the wind speeds go up. And if you've got another element that can add to that, of course it would make it strong. So that's really interesting. Let's go to 850. Now we've seen this, so this is gonna be the last thing we talk about, is just looking at that in the cross-section and kind of investigating a little bit. Here's 850 and 12Z. So the cyclone's getting organized at levels just above the ground, a little bit to the west. This is not surprising, and that's over central Pennsylvania. Very intense baroclinicity along this lengthy warm front. Look at how far it goes. It goes all the way from Lake Ontario, all the way well out to the mid-Atlantic, well off the coast of Newfoundland at the same intensity. Now, there's not the same intensity of frontogenetic activity. The temperature advection here is uniform. Here, it's anything but uniform. It's extraordinarily differential. Strong warm advection on the warm side, weak to none on the cold side. And so this is very intensely frontogenetical. And that's where we see the cloud shield. And some of the precipitation echo we saw over Maine and maybe trailing into New Brunswick. We don't have Canadian radars to add in there. But it's certainly going wild. I'm sure St. John is having a great snow day today. That might be changing to rain at some point. That's unfortunate for them. Maybe not in their odds. And here's our little cyclone. I'm sure Michael's going to tell us a little bit about this in the forecast. That's the thing that worries us for Sunday.
Worries?
Small scale. Well, I'm trying to use inclusive language. I'm not worried at all. But let's now go to tropical tidbit speed if we could. One last thing. And take a look at I think we have to use the North Atlantic domain
So forecast models.
models first. And then let's go down to regions. Look at that heavy snow. It's awesome, isn't it? And I think it was North Atlantic that worked really well. We're right there. And then let's go to 200 millibar winds is one of the options down here at Upper Dynamics, I think, where it's 200 millibar wind. Just so we know what we're talking about. So here's our major jet streak, and I think the place we really wanted to cut it was right about like that. So it'll be perpendicular to the flow direction and at what speed? Something in the 200, 210 knot range. So let's try and draw across it and use control and the cursor, I think.
Yeah, and the left button.
And draw it right along that. Great. That'll be right through it. And then, yeah, let's look at that first, frontogenesis, theta E and omega. And so I'll point you out to the north side and the south side as if you won't need it. You'll know. Yeah, this is the south side, that's the north side. These are theta E isotachs, isotherms every 5 degrees. An extraordinary contrast across this thing. It's not frontogenetic. And so there's not a lot of vertical motions. These might even be sort of gravity wave type vertical motions. You'll see them there. Let's go to PV. And this gives you an idea where the cross section is.
Isotechs?
No, not on this one, on the next one.
It's cement.
This was,
Oh, yeah,
so
so it
the
is-
very middle bottom of the.
Yeah. So look at all this activity. This is the PV and I think it's the 1.5 surfaces, the dashed line there among several, too many dashed lines. They need to have somebody show how to make a cross section, but I'm glad they do it. But look at all these perturbations of low PV up here. On the anticyclonic shear side of a 220 knot jet, right there at 200 millibars. And so here is it's a broad underlying baroclinic zone with a tendril of high PV that comes down on the cold side of it. It's an entirely weird structure in my experience, but because these are theta now, not theta E. So it's a really interesting structure, but there's the intense jet core, 220 knots, and look at all this, presumably gravity wave type activity on the anticyclonic shear side. With low PV, minus 1 PV unit, all of this stuff is really low PV from either a tropical boundary layer that's come up ahead of the storm or some other such mechanism, turbulent mixing, anticyclonic generation. I don't know how you generate it, diabatic heating or something. So it's really an interesting structure. But the jet core is kind of all cramped up. It's not one of these deep, well-constructed jet cores. And it does seem to be almost a uniformly high tropopause at about 160 or so millibars, 170 millibars. So this is all tropical tropopause on the south side of this thing. And then there's the jet core, and then some tendril comes down into the boundary layer.
So is that just a very deep and narrow fold?
I guess, and maybe it's historical, maybe like it's connected any longer to what's going on in this cross section. Because we saw vertical motions, there's no substantial subsidence there.
Mhm.
And so I don't really know what the instantaneous picture is telling me about how that got there. Yeah, so
You can also see how
it's an
those
interesting structure.
isotechs kind of creep up into the top of the cross section.
Yeah,
Under
that's right.
millibars. So that's the extension of that jet.
Yep.
Even further up into the lower stratosphere, but also the thermal gradient isn't strong enough to cap it off, right? I mean,
Yeah,
it's
that's
capped off, at 200 millibars or so, but then it slowly decays. You don't see a strong reversal in the.
Exactly right. I mean, if this
It's reversed.
legend weren't here, you'd see I think the place where there's the largest reversal, and that's minimal.
Yeah.
That's almost nothing. And then over here, there's no reversal. That's just a uniformly, it's a barotropic atmosphere at 150 millibars. Every isobar is an isotherm.
Right.
Unbelievable. So really interesting structure.
It could be the polar night jet effect. Just the reversal gradient up there is opposing, one gradient is opposing the other.
Yeah, so in the normal case, you'd have an opposing gradient here with
Yeah.
nothing above. It's really interesting. We've never seen that. We don't see it often. So that's what I wanted to show.
Okay.
Not a lot of answers, but you got to interrogate those structures.
Did you want to show your cold pool?
Oh, yeah. I only said, only for a second, we're running as the third warmest year, and I'll show you the daily time series. I like to update it every Friday until, it will stop on February 28th because we won't go past that date. This year we get a leap day, but it's not going to be in the record. So we drop down well below a standard deviation, lower than normal, and we're kind of back in between 1.5 and the average. 2014-15 had a dramatic drop in January and February, and it ends up the warmest such year. We're third right now, but we're never going to beat them because they're convergence. I don't think, there's no way we're gonna have the bottom drop out in February, and that's what's gonna be required for us to climb to the top of that list. So it'll be a pretty warm year. The first half of the year was record warm. Until we got to this point right here, we were the first. And then after that, we kind of got more like a normal year. So anyway, I just wanted to show you that. Okay, thanks for questions and comments. Greg, thanks for the Polar Night Jet stuff. Mike,
Thanks, John.
we got some snow to talk about.
Yeah. We can close the cross section. But I think one thing that caught my eye when we brought this particular map up, to some extent, I guess this region is close to a jet entrance region to this, at least if you look at the film pattern. So there's a gradient in the isotech, at least coloring. And so maybe broadly there's a lowering of pressure, but maybe there's something at the mesoscale that's helping focus that even more and make it a more dramatically deep storm. But
Well, there's also gonna be extraordinary along flow hagiography the closer you get to the ridge axis. So
Right.
there's gonna be divergence that doesn't have to do with the speed change, that's gonna be part of the curvature. And you add them together, maybe you do get a focused location. I hadn't
Right.
thought about that until you brought it up.
yeah, so interesting case, but it's not something that you would expect to see a stubbier trough that would be upstream of this.
Yeah,
All that was all missing. Let's quickly go to Solid AOS that listed EDU, please.
Sorry, say that again?
Solid AOS that was the
The
MF5.
flow is folded over itself here in the Atlantic. It's unbelievable.
So,
And we'll go down to start off with our, everyone's favorite, our meteorogram. Gotta say that word at least once a week.
It's mediocre, isn't it?
Meteorogram.
Oh,
And see our temperature, dew point, and you see, again, diurnal cycle obviously picks up, shows up nicely here. Tomorrow being a little bit colder than today, and warming up a little bit with temperature and dew points getting relatively close together, so approaching saturation at some point during the day on Sunday. And the key focus of this discussion is going to be really on the short range, the next pretty much 51 hours or so from now. So we can go to the time series of precipitation, accumulated precipitation, no, still on a meteorogram, but just scrolling down a little bit. So you can see pretty much a dry weekend is forecast until we get to Sunday morning. And then we got a burst of, let's say, moderate to perhaps heavy precipitation, or the precipitation rates are going to go up dramatically as we approach around noon on Sunday. And it'll likely be in the form of, or I'm almost certain it'll be in the form of a burst of moderate snow. And liquid equivalents, at least in this particular forecast, exceeding half an inch. So we'll be at the potential for maybe 5 inches of snow if this were to verify. But we'll get a bunch of different modeling. So next, let's go to the time height section so we get a sense of what's happening in the atmosphere above us over the next 40 to 60 hours. And we'll scroll up a little bit. Again, on this particular chart, we see the yellow contours are isotropes, so potential temperature contours. Dynamical tropopause is in green, 1.5 potential vorticity surface. Relative humidity is in red, above 70%, and increments of 10%, so from 70, 80 to 90%. And then blue are vertical motions, it's omega, but it's been multiplied by -1, so positive values indicate upward motion on this, so minus omega is plotted. And the most conspicuous thing that shows up on this map is what happens at the end of the period when we get this significant burst in vertical motion. Relative humidities throughout the column above us up to 500 millibars approach 80% in the lower troposphere, 90%, just about close to 100% relative humidity, and even a little bit of potential vorticity generation in the lower troposphere following this burst of vertical motion. This is going to be probably one of these situations, I imagine, on Sunday morning, when you look outside, it's just cloudy, like, maybe this was a blown forecast. It could still be a blown forecast for a number of reasons we'll talk about. But then all of a sudden it goes from, the visibility will gradually decrease, and all of a sudden it's just going to drop off. I think when the moderate snow arrives sometime, 8 to 9 in the morning or so as this comes in. Biggest factors we'll see when we look at the distribution on horizontal maps is going to be just the placement of the axis of heaviest precipitation. The Weather Service and a number of forecast models, including Bragg Tripoli's WNMS, are placing the axis of the heaviest snow just to our north, so more in central Wisconsin. This model is putting it kind of just to the north of us as well. We'll see that with the total precipitation amounts. But let's step back a little bit and look at the origins of this disturbance and identify a couple of things that are of interest. If we could go back, one more second, Peter, sorry.
Where are we going?
It's back to this map. The other thing that's really interesting, you can see the variant of wind with height, strongly varying with height during the arrival of this precipitation. So strong low-level warm advection is going to be one of the factors. The strong southerly, you'll see it's almost a jet of focus warm advection that comes across southern Wisconsin. Supposed to be cold enough for snow, but this localized warm advection can play one role in helping to boost our vertical motions over us. And these are pretty decent omegas. 16 microbars per second. Okay, so let's go back to the horizontal maps. We'll start at 500 millibars and we'll go to at 12 hours, 6 hours in the forecast. Right around now. So that, I believe this is the feature that's going to be of interest, the shortwave trough that we saw some evidence of in the 500 millibar analysis that John was looking at on superpeats. We can see this morning how it's a nicely structured, nice curvature change from cyclonically positively curved to negatively curved. So decent vertical motions would imagine associated with that feature. We talked a little bit about that in 311 this morning, part of the review. Along the East Coast, you see this strung out area of vertical motion. That's kind of that linear band of vorticity. It's not a very exciting structure, but it's just structured well enough to support this deep cyclone that's off the East Coast this morning. So let's look at the evolution of this. We can just step forward in time. We'll do it every 12 hours from the 6 hour forecast. So midnight tonight, that's pretty close. Midnight tonight, you see really nice, well-developed upper trough just over Seattle and Vancouver in this northwesterly flow. And we'll just keep going. Another 12 hours to midday tomorrow. Okay, then it begins to lose its structure as it crosses the mountains. Again, this is in part just sort of stretching and shrinking as it goes across the mountains. It's less compact, but still pretty decent in its structure. What we're interested in, if you want to see a really nice, robust disturbance, is going to be a change from cyclonically curved to anticyclonically curved. That change in curvature supports sort of a packet of very strong divergence, which can support significant upward motions. So let's continue forward. So this is AT&T tomorrow. And then this is midnight tomorrow night. And we've lost a lot of that structure with the upper trough, but you can still see it right here. Very modest cyclonic anticyclonically curved flow, decent sort of downstream vorticity advection ahead of the trough. But again, nothing that you would get super excited about at this point. Let's go to 18Z on Sunday. And then the trough arrives over us. Again, not the most robust feature that you would like to see for significant snow, and still upstream of us in terms of vorticity advection. Let's also look at the surface map at this point in time. Let's keep the vorticity maxima here and the downstream advection. So the surface map, 6 hour precip. Again, so we have downstream of that a nice region of ascent that's downstream of this, the thermal wind, the advection by the thermal wind of that vorticity at 500 millibars, it's downstream. So this would, again, that all supports a really strong vertical motion maxima over Wisconsin by the time we get to around noon on Sunday. So I think the heaviest snowfall will probably be around noon, but then it's going to cut off pretty much shortly thereafter, by 3 or 4 o'clock, this should be over. Let's step back at the surface map and let's look at the arrival of this system. But let's go to we'll quickly go through the same sequence of maps we looked at. We'll start warnings. There's a cyclone making landfall, but that's not the cyclone we're going to be tracking. That kind of disappears as you go over the mountains. Let's go ahead 12 hours. So you can see this beginning of fill 1001. Again, all the varieconicity is concentrated in this ribbon that's well to our west. We're in this region of fairly weak varieconicity. Okay, we'll go ahead to noon tomorrow. Still weakening 1004, but there is still at least some semblance of a surface disturbance. It's kind of a almost Alberta Clipper-like disturbance, but you can see this ribbon of very strong varieconicity. So this cyclone's going to track along this ribbon downstream of it in the region of strongest warm advection. Let's go ahead. Another 12 hours. Moves into the plains, the central plains, 1005. And it looks super exciting at this point. But you can see a nice thermal ridge here as this disturbance rides along this thermal boundary. And the fact that the cyclone is pretty close to the thermal ridge axis, at least the way that I would interpret this, is that at least the upper feature, that upper trough, is probably not having, at least at this time, as strong an influence. I agree. If we were to invert it and then look at the circulation at the surface of the upper trough, it would probably be relatively weak at this point. Okay. So looking at this, I think you'll look at, following where the strongest warm advection is, this is going to progress somewhat to the east over the next few hours. So let's go to 54 hours, the time when the heaviest snow should be arriving. There's our cyclone. It's moved back now. This is kind of interesting. From where the thermal ridge axis was, the minimum pressure is back here. So there's now at this point been some recoupling of the upper wave with the surface cyclone, and that's going to help with the strong precipitation. We can look at vorticity advection by the thermal wind. We can also look at some Q vector convergence. Let's go to 12Z tomorrow. Let's go to the 12Z map, 700 millibar Q vector convergence. That's a really nice display. So this is 48 hours. Sorry, 48 hours. Q vectors down here, 700 millibars. Oh yeah, I can't tap that. So this is kind of zoomed in over the upper Midwest and plains, and you can see in red is the Q vector convergence. You can see it's nicely concentrated. This is Sunday morning 12Z, just to our southwest. Perfect. So this is really a nice region. Again, we have the water vapors being delivered to that area. This is going to be great for producing significant burst of snow. Let's go ahead 6 hours after this, the 18Z. And it's right over our state. I think the strongest Q vector convergence is maybe slightly to the north of us, but this is a pretty good.
It's a nice combination of both phylogenetic and wave scale at the same time, because the components are.
So you can see here, these Q vectors that are pointing from cold to warm, indicating phreноgenesis. And if we actually were to look at 850, let's look at 850 map at this point, please. You can see that phreноgenesis that John was just referring to. Look at 54 hours. You can see the component of this flow that's normal to the isotropes weakened as we go northward.
Yeah.
And so there's phreноgenesis in this band. And so one of the critical things in this forecast is going to be, where does that heavy precipitation start? And what's the gradient going to look like? We're going to be on the northern part of the gradient, southern part is going to be well to our north. We can click out of this and go back to the surface map. Look at the total accumulated precipitation. If we go back and click, sorry, Pete. What do you want the total? Oh, the total, yeah, that's going to be right here. I don't know if this is going to give us that. So through 60 hours, so the axis of the heaviest is also just to our north, and we're in this last closed fill pattern, but you can get a sense of the axis. This is just a little to our north, get a county or so north of us. If we look, go down to the zoomed in 30-kilometer maps. Now let's go to 42 hours. Okay, so this is going to be at midnight tomorrow night. Okay, so this is early Sunday morning. Again, all the precip is out to our west. Let's go to 12Z Sunday morning, 48 hours. Yeah, this is the accumulated precip over the 3-hour period ending at this point, so it hasn't quite arrived here by early morning. Okay, but it's snowing pretty heavily down out to our west in southern Minnesota with the southeast wind. Also something that gets you nervous. Oh, southeast wind will warm up, but no, it looks like we're cold enough. Let's go ahead 3 hours from that, 51 hours, should be 9 a.m. And there we are with the snow just arriving, and it's going to be right after this time period. You can see the axis of the heaviest accumulated precip is just to our north. Let's go ahead another 6 hours, or 3 hours, 54 hours, right, just to our north. But you can really see the confluence in the flow right along these isotherms even at the surface, some surface phreноgenesis as well. So it's really nice, a nice setup. And the surface cyclone out here to our west. Let's go 3 more hours at 57, the mid-afternoon on Sunday. And you can see here, again, that the heaviest accumulated precipitation is just to our northeast at this point, but we're still receiving snow. And then the final map time, you see that this is just about over. If the upper trough were a little bit stronger, I think one of the concerns would be maybe a dry slotting of this whole event and then shutting off earlier. Looks like we'll have some good snow that lingers after 3 in the afternoon for the heaviest amount move across Lake Michigan into western lower Michigan. So a nice period of snow coming up. We can get a couple quick different perspectives. We go to the Pivotal website. I don't want to go longer than, you can't go as long as 1:15, but people got to leave. I don't want to hold you up. Okay, let's zoom in first regionally. Go to regional and then go to here. And then let's go to just winter weather Total accumulated with a regular, and then let's go to 60 hours. Okay, so this is the GFS forecast, about 5.2. That's kind of consistent with the NM5 forecast in terms of accumulated precipitation by Sunday evening. Let's switch models and go to the NAM. Over up, please. Yeah, right here. Yeah, click on that. Yep. Okay, 5.2, 2.0, and then everything, the heaviest band is well north. Let's go to the Eastern WF. That's in. Oh, look at that one. That's 4.6. It's a little bit further to the south.
It's like a compliment.
4.6, yeah. And then we can look at a couple others. The GDPS, which is a Canadian model. That's just really weird. Well to our south, has a little band here at 2.7. And then finally, the UK Met, which is also available, about 4.5. So, probably 3 to 6 inches is probably a reasonable forecast for us for this next event. If we go back for just a moment. And look at the GFS 3.1, the regular GFS, not the high res one, please. And go from Midwest to national. Just blow this up. Let's go to just the surface and preset. Oh, okay, so that cyclone's sort of out of here by the time we get to Monday evening, and we just every 24 hours, so we go to 70, or let's go to 84 hours of this forecast. Okay. But Monday looks like it's gonna be a decent day with an anticyclone over us, weak warm advection at best, or weak temperature advections in general. But probably a nice day, but a cold morning with a fresh snow cover on top of us. We'll go to 120 hours, please. Jumping really far ahead. Good story. Tuesday's Wednesday. Oh man. Again, westerly winds, warm advection occurring, and anticyclone is sort of suppressed to the south. Really a nice cold advection across southern Canada at this point. You can see a nice Arctic front that's going to be well more north of northern Wisconsin. The question is, what's that going to make it to the south of us? Let's go to 144 hours. For 12 to Thursday, that cold air does come in, but it's only just a glancing blow. It's not super cold over us. But the interesting thing about Thursday is if you look at past forecasts over the last week, we've gone from maybe an extended period of snow and significant snow over us to this whole weather system being suppressed to the south. If you go back on the forecast, runs from, let's say, Monday of this week, 12 to Monday. That doesn't look snowy at all, does it? Let's go to Wednesday of this week. I'm sure we get snow in the forecast. Missing something?
I don't know.
Period?
I don't remember that. I remember the cold was coming in and varying degrees of intensity. This was more intense than the other.
Right, so maybe it was even earlier than this when the snow was ending, but basically we're gonna get through the week relatively dry, but this is not gonna be as cold, at least the forecasts aren't as cold for this next Arctic outbreak. If we could go back to the current run. And then just go forward to 168, so a week from today. Please. And pretty mild weather after that. And then it's like this next cyclone's gonna track maybe slightly toward north.
Yeah.
168 hours and go to 192. Long weekend.
Washed
Warm
out.
advection again, so things are just washed up, flow kind of relaxes. So a pretty quiet week coming up if the forecast holds the way it is. A glancing blow of cold air middle of the week after our snow on Sunday. So pretty decent weather. It's kind of typical of this time of year. Nothing harsh, maybe slightly above normal temperature, perhaps, for the balance of the week. And that's it. Thank you very much. Thanks, John, and thanks, Pete.
Ketzel says the precipitable water looks pretty interesting in this one.
For the current snow.
Yeah, for this one.
So this precipitable water is just a vertical interval of the water vapor, the mixing ratio from the surface up to the entire column. And so see this tongue of really moist air that gets affected to highlight, which is this is now Monday after the event's over. Right. we tapped into this really deep moisture early on, we might have gotten
Yeah,
a
better
chance
chance.
of even more snow.
Need a stronger wave to the west. As you said, that the wave kind of doesn't get far enough south and decays. If it had been a little stronger and got to about the Salt Lake, it'd be a whole different story.
Right. So this is one of those things that 15, 20 years ago, we might have said, well, wait till that wave gets onto the North American Radio Sun network. But now that we have lots of satellite data, this is probably pretty well observed, but never know. Let's watch as this comes on. Maybe
Yeah.
the forecast will change dramatically this evening once that disturbance that was off the west coast of the United States makes it into the Radio Sun network, and just more surface observations to constrain the uncertainty.
I didn't show the satellite in the west. I should have, because I did it in class. And that wave has a really nicely developed comet associated with it crashing into the British Columbia coast. So it's not going to fool us in terms of being a prolonged upper frontal development before the breakdown into a vortex. And so that's the only hope you'd have for getting a little further south and a little more intense on this one. So, yeah, what you just said, I completely agree. I think we know what's going to happen.
It's always good to say that. It sets us up to be.
Yeah, that's right. See, look at that. That's a really nicely developed wave. I'd rather see a dock strip along the coast and then say, oh, maybe that'll dig all the way to northern
And
Utah.
this strip being even darker up here. Or
Yeah,
not being
right.
as developed as it is right now,
Yeah,
perhaps.
yeah, that's right.
So that's the feature that's gonna give us the snow event. But the Weather Service is contemplating winter storm watches for just north of us for Sunday.
Yeah, it's going to be a good day.
All right. Well, thank you very much.
Thank you, Michael. Thanks, Pete. Yeah, hungry.